Hello everyone and welcome to another tutorial. Today we are going to be looking at this slider crank mechanism, and we are going to do each component so we can create the assembly and then at the end perform this motion study as you can see here. So let's start with the base, and the base is just a simple rectangle with a few holes, and the thickness of that base is a quarter of an inch. So let's begin. So I'm gonna exit this and let's create a new drawing, new part. The units are in inches, so that's okay. So for that plate, I'm gonna take the top plane to create the sketch and select the center rectangle, and let's define. This is 12 and depth is 4 inches, and now we can hit OK. Thickness of the plate is a quarter of an inch, and we can do mid plane for this. Now let's create the holes that we need. So the first hole is around this area here, and dimension is half an inch, and the distance from that edge looking at that drawing is 1 inch. Now we can do the other 4 holes that we need. This one is a quarter of an inch, and the distance from the edge is 0.5, and to that is also, this is 3/4. All right, so once we have that, we can create a relationship between these two. So I want these two to be equal to each other. Let's select this one as well. All right. Now let's dimension this hole as well. 3/4 and half an inch from that edge. And the distance from these two holes are 8.5. So we can also define this one here, 8.5. This is 3/4. And lastly, let me dimension this one here is 0.25. So we have all the required holes. So now we can proceed with the extruded cut. All holes are selected, and right here through both directions, and hit OK. Finally, we can just create a quick fillet, and we can just leave it 0.10 inches. So let's select that face, and this face, and that face too. And let's hit OK. So we have created the base. So after you do that, we can save, and we can name this base. Let's just do base 1. Okay. All right. So the next component that we're going to do is the crank shown here. So let me see if I can bring the dimensions here. So we have the dimensions for the crank, 2 inches center to center of the hole. This hole right here is quarter of an inch. The outside diameter hole is 3/4, and we can start with that. So let's create a new part. And this time I'm going to take the top plane to create sketch. Select the circle, and we'll provide dimensions at the end. Okay, so now let's define this diameter. This is 1.5. The inside circle is 0.5. This right here, it's 3/4 of an inch. And the inner circle is quarter. Okay, now the distance from center to center, this is 2 inches. And now we can connect the two outer circles with the line. So make sure that this line is tangent to the circle. So you just hold Control key and select both and tangent. So you can see the tangent symbol. So this is also tangent, so that's fine. Now let's trim the inside lines, so we don't need this. It looks like this line right here is not tangent, so let's see if we can provide a relationship. There we go. Let's provide a thickness, and the thickness of this looks about quarter of an inch. So let's put it here 0.25 inches. And I always like to do mid plane, and let's hit OK. So now looking at the at this component, there is a cutout here, and there are some fillets around all the edges. So for that, we can use the shell command. So let's click on shell, and let's select the face that we would like to cut, and then let's select this box to show a preview. And that looks okay to me, and let's hit OK. Let me go back to so the thickness is 0.10, and that will be the thickness of the wall. So let's hit OK. Now we can just apply a fillet, and 0.10 is the fillet. That's okay. Let's select all the edges that we need, and let's hit OK. And that looks good to me. For this one here, if you want, we can apply a color, so we can see red. That looks good, and we can save this, and we can name this crank 1. The next item that we are going to create is the slider. The slider looks like this, and if we go back to the assembly, this is the slider that we are going to create. Okay, so we have the thickness of the walls are 1/2 inch. The depth, the height of that is at 3/4 of an inch, 9 inches, and 3 inches in depth. So with those dimensions, we can start creating the slider. So let's create a new part. Using the top plane, let's create a sketch. I'm going to just provide a center line so I can use this as my reference. All right, so now we can start sketching, and actually, let me go all the way down. At the end, we will provide the required dimensions. For now, this is just an approximation, and let's close. All right, so this distance here is 9 inches, and the thickness of this, as we saw, it's half an inch. Same thing on the other side, 0.5. The thickness on this side right here is also half an inch, and this dimension is 3 inches. Okay, let me create a center line this location so we can provide a dimension here, and I want this to be, actually we can move this and delete that center line. We don't need that center line anymore. And let's take the center, the origin point to the edge, and make this 1.5. So that will put the sketch at the center of the origin. Always try to be to use that symmetry as much as possible. This will help you when doing assemblies, so you can select the center of the part. So it looks like we are good with this is a fully constrained sketch. So let's provide a thickness, and the thickness of this is 0.75, 3/4 of an inch. And let's hit OK. So now looking at this component, so we have fillets at all the edges, and the fillet is 0.10 inches. So let's take the fillet command, and let's select all the faces, even the inside faces. Okay, so let's hit OK, and that looks good to me. We can apply a color to this. Let's see what's good. Let's see this blue. Okay, and we can hit save and call it slider 1. Okay, the next component will be the moving block, and that moving block is this block right here. So let me bring the dimensions. So the thickness of that moving block is 2 inches by 3 inches. So 2 inches is this smaller section. The bigger one is 2.5. And with these dimensions, we can go ahead and create the block. All right, so let's create a new part. Always make sure the units are the ones that you prefer. So let's take the front plane for this sketch, and just gonna create some center lines for reference. Okay, so now let's start sketching. As always, this is going to be a approximation of the um, of the actual block because we're going to provide dimensions at the end. Okay, so the block looks something like this. And let's hit close. All right, so this dimension here, as I mentioned at the beginning, this is 2.5. 2.5. This right here, this is half an inch. Okay, and this right here is 2 inches. So I want this line and this line to be equal. So I can just select both and make those two equal. The the distance from the top to the bottom, this is 1 inch. Okay, so that's 1 inch, and this dimension here is, actually let me take the other one. So this one here is 1/4 of an inch. So with that, we can take this and select the other line and make these two equal to each other. So it looks like they are already equal to each other. So we can select this and delete so we don't get that error. So these two are already 1/4 of an inch because of that dimension and these two dimensions right here. Um, so we have the 1 inch, 0.5, 2 inches at the bottom, and it looks like the sketch is fully defined. So we can hit OK. And now let's provide a thickness. And if you recall, this is supposed to be 3 inches. Okay. So now that we have that, let's go back and look at the block. So there are some fillets at all the edges, and there is a hole at the middle. And that hole is 1/4 of an inch with a depth of 1/4 of an inch as well. So let's apply the fillets. Let's hit on fillet. That the fillet is dimension, that's okay. So let's select the faces. So we need that face. Pretty much we're selecting all the faces. And that looks good to me. Next we can create the hole. So select the top face and sketch. And the hole will be right at the middle. So we can hole is 1/4 of an inch. Okay, so now let's hit OK and make a cut. So for this one here, we're just gonna select the blinds, so it'll go to one direction only, and the depth of that hole is 1/4 of an inch. And let's hit OK. And there you have the moving block. So we can save the model. Before that, we can let's apply some color to this. Let's see what we can apply. We can apply a solid color. Let's make it yellow. All right. So let's save it. And this is, we can call this moving block 1. The next component that we are creating is the link. The link is this part right here. So that link has the following dimensions. So it is 6 inches center to center of the hole. The inner circle is a quarter of an inch, and the outer diameter or radius is 0.25. This 0.13, that's the thickness. So it has been rounded up. So the actual thickness is 0.125 inches. So with these dimensions, we can go ahead and create the link. So let's create a new part. So for that, we're also taking the top plane and creating a sketch. There is this is called the center point um, stray slot. So let's select that in order to create that link. So what I'll do is it'll take the center point and we'll do the both sides in a symmetric way. So click and now click one more time to provide the thickness, and let's provide a dimension. So if you recall, the center to center distance is 6 inches, and the outer radius for this is 1/4 of an inch. Okay, so now let's create a circle so we can make the cut, and the thickness of this is 0.25 in diameter. Okay, so now selecting that circle and this, I want to create a relationship and make those two equal. So now this became 1/4 of an inch. And let's hit OK. And let's provide a thickness. The thickness is 0.125 inches. And let's do mid-plane. And let's hit OK. Let's give it a different color. So green, and save. We can name this link 1. So the other components that we need to create is this shaft right here and these two pins. There are also a few bolts at this location. So for the bolts, we are going to use the toolbox that SolidWorks has. But for the pin, we're going to model the pin. So let's begin with this pin right here, with that shaft. And that shaft is just a simple half an inch, and the height is 1.5. All right, so let's create a new part. Let's select the top plane and let's create a circle. This is 0.5, and the height of the pin is 1.5. 1.5 mid-plane, and let's hit OK. And let's give it a color. It's pink. That looks good to me, and can call this shaft 1. Okay. Now let's do the really quick the pen. Let's do a new part. Similarly to the shaft, select the top plane and do the sketch, and let's define this. pin is 1/4 of an inch. Let's hit OK. And the height of the pin is going to be 0.375 inches. And let's hit OK. And let's give it a color to that, probably orange. That looks good. And let's save this as a pin 1. Okay, so it looks like we have all the components, and we are ready to begin with the assembly. So we have the base, the shaft, the crank, the link, the moving block, and the slider. So next we'll do the assembly. Now that we have created all the components, we can proceed with the assembly. So let's create a new assembly. Let's just double check that we have the right units, IPS, which is in inches. So let me bring up the assembly. So we're going to start with the base, and this component is going to be fixed and is going to hold all the other components. So let's close this and let's click on Insert Components, and the first one is going to be the base. You can select one by one or select as a group. So for now, let's select this one component, and without clicking on the graphics area, let's hit the check mark. And this is already fixed, denoted by the F letter. So if you want to drag it, you can see that message. The selected component is fixed. So now let's bring the rest. So let's bring everything as a group. So we can highlight all of them and click on Open. This is a quick way of inserting all of them. So you're gonna do one by one. You're just gonna click on the graphics area for each component. So after we have all that, we can start assembly. So let me take this shaft and make that concentric with this hole. So holding Control key, select both and select concentric. Now the bottom section, I want this to be flush with the bottom section of the plate, so I'll select coincident. So now this pin is free to rotate only. Now let's bring the crank. Similarly, I want these two to be concentric. And I want the top face to be flush with each other. So right now these two are not connected to each other, meaning I can rotate the crank but not the shaft. So I want these two to be connected to each other. So for that we can go to the let's go to the shaft axis. We can select the front plane for the shaft, and holding Control key, let's go to the crank and select the right plane and make these two coincident. So right now, if I rotate either the crank or the shaft, they both rotate. They are fixed to each other. Now, let me bring the assembly so we can follow. So right now we have these two. Next, we can bring the pin and the link. So the pin is right here, and similarly we can make these two concentric, holding Control key, make these two concentric, and the bottom of the pin, I want that to be concentric, flush with the bottom of the crank. So now let's bring the link. So the steps are pretty similar. These two are going to be concentric, and I want the link and the top of the pin to be flush with each other. So select coincident. All right, so next we are going to bring the slider. So the slider, first I want this bottom face to be coincident with the top face of the base. Okay, I want this face align with the back face at a distance of, let's say, 1/4 of an inch, and let's hit OK. So that means that this face and this face right here, they have a distance of 1/4 of an inch between the two. So also I want this slider to be at the center of the plate. For that we can use there are a few ways to do that, but let's use the planes. So we can use the base. Let's go to the base, and the base is right here. We can select the front plane of the base. Now let's go to the slider and select as you can see, the front plane of the slider. So with the control key. So let me do it one more time. And make this coincident. So so I have a fully defined slider fixed to the base. Finally, we need to bring the block, the moving block. So I'm just gonna align this a little bit the way I would like it to be. So select the bottom face of that to the bottom face of the plate, and let's make that actually, let's select this face here, because this is the face that will be aligned with the slider. Select that, make that coincident. Now now we can drag this a little bit and select this face. I want that to be coincident with this face right here. Okay. So now my moving block can only move on the X direction. Okay. So we need to bring the another pin so we can connect these two. So for that, let's go back to Insert Components and select the pin. And let's put it here. Let's create a concentric relationship between the two. And I want the bottom face of the pin to be coincident with this face right here. Okay. And finally, we can make these two coincident. And we have a we are almost done with the assembly. So if I rotate this, they are all connected to each other. So one thing that I want to mention is, if you look at the assembly, um, there are 4 bolts that is connecting the slider to the base. So we need to create holes on the slider before I bring the bolt. So let's make those holes first. So one thing about this, good thing about this assembly is that we can right click on the component and we can edit part like right here at the assembly. So let me save first. I'm going to save this. So if you notice, everything is now hitting lines, and the component that we would like to edit is solid. So this is a good thing because I can create the holes right here at this from the assembly. So let's select that face and click on sketch. And since I already have the holes for the base, I can use the same sketch to create the holes for the slider. So I don't have to go back and see the dimensions and locations of each hole. I can just do it right here, and the part will be automatically updated. So once I do all the 4 holes, 4 circles, I can now go to features and extrude cut, and I want these holes to be I can select through all the part, and let's hit OK, and let's exit. And now this part has the holes at the right location. So if I want to open up this part individually, it's gonna have those holes already. All right, so now it is time to bring the bolt, and for that we can go to the toolbox that SolidWorks has. So we're going to be in the ANSI inch, and let's select the bolts and screws, and we can select the hex head for now, and select the hex bolt. You can just drag it. So I want this to be 1/4 of an inch in diameter, because that's the diameter of the holes. And I want this to be, we can set this to 1 inch, the length of the bolt to 1 inch. After you do that, we can hit OK. And we need 4, so we're just gonna right click on the graphics area for the quantity of the bolts. Okay, so we can hit escape, and now we're ready to locate this at the location that we want. So I want this to be concentric, and the bottom of the nut to be coincident with the slider, and we'll repeat the same for all of them. So just gonna do that right now. This is bolt number 3. So let's apply. And finally, we can bring the other one here. Let's rotate a little bit. So make that concentric and these two faces coincident. So we have a fully assembled slider crank. So now from here we can go to the, if you see here, there is already a motion study one, so we can click on that and we get into the animation and motion interface. From here, there is a properties settings for the motion. Here you can find the frames per second, and for the animation basic motion, you can play around with this. For this particular assembly, we are gonna change this to let's make this 200 frames per second so we can get a better visualization of the animation. We can click OK. Um, this shaft, we are going to assume that this is a motor shaft. So this is going to be connected to a motor. So there is this icon right here that is going to simulate a motor. And now we get into the motor property. So we're going to keep rotary motor, and the component, under component direction, we have two options that we need to select. So this is the motor location. We're going to select the shaft, and the axis is going to be also the shaft, which is already selected. So right now the direction of the motor rotation is counterclockwise. If you want to reverse that, we can click on this and it'll reverse it for you. For now, we'll keep it. And the RPMs, we're gonna leave it as 100 RPM. And over here, constant speed, just gonna leave it like that. And we can hit OK. So this is the playback speed, and it is a multiplier of how it's going to look in real life. So I want this to look a little slower. So I'm just gonna select 0.5, and this is the calculate button. So this is going to calculate all the inputs that we just selected. So there is another thing that we can do here. So I want this simulation to run for about probably, let's make this at 3 seconds, or let's make it 4 seconds. You can put as many seconds as you wish. And now let's hit on calculate. You can kind of see how the simulation is going to look like. So after it calculates, you can click on play, and this is how you will do a motion study of a slider crank mechanism. And this concludes this tutorial. I hope you enjoy, and thank you for watching.